Welcome. This video will demonstrate the use of Scratch to create a simple game and introduce some pedagogy for teaching coding. Scratch is a versatile platform that enables students to use block-based coding to create a variety of projects. Students can create stories, games, animations, simulations, music, and art. The project demonstrated in this video will be a game. There are many different types of games that can be created with Scratch. Students can create classic games such as Pong or scroller type games like Super Mario Bros. They can even create catch games where the player moves a sprite along the bottom of the screen to catch items falling from the top. The type of games that can be created with Scratch are limited only by your imagination. In this video, the cat and mouse type of game will be demonstrated. So what is a cat and mouse game? A cat and mouse game is all about pursuit and capture. In this game, there will be a sprite controlled by the user, for example a mouse, and then the goal is to try and catch a target, such as a donut, all while being pursued by an enemy like this cat. So the first step in creating any program is to make a plan. This involves understanding the problem and planning the algorithm. I'll talk more about this later. For the sake of brevity, I've outlined the steps to create a cat and mouse game here. So first, what we need to do is choose our sprites and background. Then, we need to code the control for the mouse's movement, which is going to use the keyboard arrow keys. Then, code making the donut move to random locations, and similarly, code the cat to go to random locations, but this time it'll be a glide. And then we're going to add points to the score when the mouse catches the donut, and subtract 1 point from the lives when the cat catches the mouse. And then finally we need to end the game. And the game will end when either the lives reach 0 or the points reach 10. So now let's put this plan into action and make a Scratch game. Feel free to follow along and make your own Scratch game. You can pause the video and rewind as needed. Ready? Let's code. To get started with this project, we open up the Scratch interface in the web browser, and we've logged in. And we're just going to go over here and click on Create. This is going to create a new Scratch project. Here I'm going to give it a title so that I can save it and share it later. Cat and mouse game. And let's get started with the first task that I outlined. We need to choose the sprites and background. So to do that, we're going to come down here. We're going to get rid of the default Scratchy cat. We're going to add some new sprites. So we come down here, look where it says choose a sprite, we click on this, and we have this whole library of sprites that we can choose from. And here I want a mouse, so I can search for that, and I add a mouse. We'll go ahead and add another sprite. We're going to add the donut, and then let's add the cat. There's a variety of cats here. I'm going to choose cat number 2. So now I have my sprites, and you can adjust them anywhere you would like on the screen. And then we need to add the backdrop. So I can choose the backdrop here, and in this case I'm going to go with one of the room backdrops, and I'm going to choose room number 2. Because this will provide me with some nice contrast between the colors of the cat, mouse, and the donut. Now you notice it seems like the donut is a little too big, so I'm going to go ahead and scale that down to about half size. And then, oops, I scaled the mouse. Well, I wanted to do that anyways. So then we click over here on the donut, and we can scale that down, and now we have the sprites approximately the size that seems proportional. So now we've completed step 1. On to step 2. I want to control the movement of this mouse by using the arrow keys on the keyboard. So how can we do that? Well, an arrow key is simply an event. So pressing that creates an event. So we come on over here to our events and we look for one that has to do with the key press. Have up here when space key is pressed, and we're just going to change that to an arrow key. Let's start with the up arrow. So for the up arrow, we want the mouse to move up. So that's a movement. So we come over here, we look for the motion category, and we pull out a move block. Now, when I try this out, let's go ahead and press the up button, and it's moving to the right. How can I change it so that it moves up? Well, also in the move category, we can change the direction in which the mouse is pointing. So we can pull this out here, add it in to our key press event, and I'm going to change this to point directly up. So now when I do this, the mouse points up and moves up. Now, how do you think we will code the remainder of the buttons? Very similarly. So we can just duplicate this code. And you see that I laid it out similar to a directional pad. So I'm going to change this to the left arrow, right arrow, and down arrow. Now the only thing I need to do is change the direction on each of these. So we'll move to the left, move to the right, and then move down. So let's go ahead and try that out. And moving up, moving down, to the right, and to the left. Alright, so everything works there. We've now completed step 2. Now let's move on to step 3, and we're going to make the donut move to random locations. Now to be able to do that, we need to put the code on the donut. You see here, we have the mouse highlighted, so all of this code only applies to the mouse. We move over here to the donut, we see that there's no code yet. So we want to move the donut to random locations throughout the entire game. So it's just going to constantly keep moving. So how could we do that? Well, we can use a control element here called a loop, and in particular we're going to use a forever loop because we want it to happen continuously throughout the game. Now, how can we get it to move to random locations? Well, move is another movement block, so we go up here and we're just going to pick go to random position. So there we go. But if you notice, this is just a loop standing by itself. How does it start? So we need an event to start it, and a standard one to use is just when the green flag is clicked, and that way it starts up when the game starts and runs forever. So we go over here, we can test it, click the green flag, and we see, oh my goodness, that donut is just moving everywhere, moving extremely fast. So probably too fast to catch. So how can we slow this down? Well, we can add in a wait block. Here we go. And if we click, it's set to wait 1 second here, and we click the green flag, there it goes, it moves. Now that's still probably a little fast to be able to catch it by moving the mouse around. So I'm going to go ahead and slow this down a little bit more. We'll make it wait 4 seconds. There we go. That seems pretty good. And you can change the speed at which it moves around. All right, now let's move on to the cat. So again, we're going to come down here. We're going to put that code on the cat. So we come over to the cat, and we want the cat to kind of glide across the screen, kind of simulating chasing the mouse. It's not directly chasing the mouse, it's just moving around all over the place. So how can we do that? Again, that's another move block. And we want it to do it constantly, so again we're going to use that forever loop. So we pull that out here. We look at our motion blocks, and remember I said glide, so we're going to use that. We're going to have it glide across the screen to a random position. So that's what this is going to do. It's going to glide to a random position over the course of 1 second. And then, so that it starts and runs throughout the entirety of the game, we're going to add the green flag click event trigger. Put that over here. So now, when I click the green flag, we're going to see the donut move and the mouse or the cat move around. So there we go, the cat's moving around. He might be a little fast for us to be able to avoid him. So I'm going to change this to 2 seconds. So it's going to glide to a random position over the course of 2 seconds. So stop this and restart it. There we go. The cat's slowed down a little bit. All right, that takes care of step number 4. Now we're on to step number 5. Now in this step, we wanted to add a point to the score when the mouse catches the donut. So how do we do that? Well, we need to be able to store this score, these points, in something. And how you do that is with the use of a variable. So we come over here, find our variables, and we are just going to make a new variable, and we'll call it score. Keep things simple. So now we have this variable called score. And we want it to increment when the mouse catches the donut. So we're going to come back over to our mouse here. We're going to put a little more code on the mouse here. And first thing we need to do is decide how it is we're going to know when the mouse is touching the donut. So how do we know that? Well, if the mouse is touching the donut, we add a point. If it's not, we don't. So the key word that I use there is the word if. So we come over to our control and we find an if block. So we drag that out there. And then for the if block, we have this if, and then we have this trapezoid type shape here, 2 pointy ends, and then the word then. So the way this is read is if this condition, what we're going to put in here, then we're going to do whatever blocks are inside of this. So our condition is when the mouse is touching the donut. So we can come back up and look for the sensing blocks here. So this is the sensing blocks, and we see one for touching mouse pointer. So when we bring that on, what this is going to do, this condition is going to return a true if the sprite that it's on, the mouse, is touching the mouse pointer. And we're just going to change mouse pointer to donut. So now it's if the sprite, the mouse, is touching the donut. It's going to return true. Otherwise, it's false. So we add this into our conditional. And now we want, so if it's true, we want it to increment the score. So we go to our variables, and we are going to use this change variable block, put it in there, and we're going to change it to the score variable, and we're going to leave that as 1. So now we're changing the score by 1 whenever the mouse is touching the donut. Alright, so how do I get this started? How do I use it? Again, we want this to be something that the game is constantly checking, so we're going to go back to that forever loop again. Seeing a pattern here? I hope so. So we're going to put this in a forever loop because we want it to constantly be checking it, and we want it to start at the beginning of the game, so we're going to use the green flag click here. So now when the game starts, it's going to constantly be sensing and looking for whenever the mouse is touching the donut. So let's try that out here. We're touching the donut, and you see here this value of score in the upper left corner of the stage. It jumped up to 121 just because I touched it for a few seconds. That's because it's constantly doing it, constantly checking it every second. So similar to how we did to slow down the donut from jumping around so fast, we're going to add in the wait block. So we're going to add this in here, and I'm going to go ahead and set it for 2 seconds. That should be enough to work. So now we have step 5 done. So now when I stop this, start it again, move this guy around, score only incremented by 1, incremented by 1, incremented by 1. So that's working well. But you see that the score is at 127 still. I need to do one more thing here to get this to work right. I need to actually initialize that score variable when the program starts. So we're going to bring out the set block. We're going to lock it in here. So to initialize the score variable, we want every time the game starts that score to be set to 0. So we're going to set score to 0 using this block. So now when I restart the game, here we see in the upper left of the stage the score is set to 0. Alright, so now moving on to step 6. We want to subtract a life from the mouse every time the cat catches him. So that's a very similar process to what we just did with the score. So we can go ahead and just duplicate this over here. And now let me shift the blocks around a little bit so we can see this clearly. I'm going to create a new variable for lives. So we're going to make a variable, call it lives. And again, we should initialize it to some sort of value to start with. I'm going to use 10. So we start with 10 lives. And now here in the conditional, it's not going to be when it's touching the donut, it's when the mouse is touching the cat. So we can just change that to the cat. And we're going to change lives by, and we can put in negative numbers here, so we're going to do -1. And again, we're going to keep the wait block in there. That way it doesn't just dramatically go down every time the cat touches the mouse. Alright, so let's try this out. Let's stop this, start it, and okay. Move my cursor out of the way so you can actually see the numbers. Okay, lives have already decreased by 2. I got 1 when I got the donuts, and I lost a life when the cat touched me. So that's working the way we want. So now we're going to move on to the final step of this, and that's to actually add an ending to our game. So right now this game would play on forever and just keep going. So now we need to end it, and our ending scenario is if we get a score of 10. So if we reach a score of 10, or we lose all the lives. So lives is 0. So again, similar to these other blocks, we are going to use a forever loop because we want this to constantly be running throughout the entirety of the game. So we're going to go in here and look at our control blocks, pull out a forever loop, and again this is going to start when the game starts, so we use our green flag click, and now we're going to in here check for 2 different conditions. One, if the lives have reached 0, so if they've reached 0 they are less than 1. So let's start with that one. So we use the if then block again, and we're going to put a conditional in here. Remember, before we used that sensing block. Now we're going to have to build our own conditional to evaluate the true and false. So we come over to operators, and in this case I'm going to use the less than operator. So this one here, I'm going to drag it on and put it in there. And right now you see it's got this empty space less than 50. Well, what I'm checking for is the lives in this case. So I'm going to use the variable lives. So we come back to our variables and we just pull this one out here. The round ones with nothing else, that is just using the variable and the value stored in that variable. And we are going to say if it is less than 1. So in other words, it's 0 or negative numbers, anything less than 1. So that's when the game will end. So we want to do something to end the game. And here I'm going to keep it simple. We're just going to use one of the say blocks. We're going to use this say for 2 seconds, and we'll say just game over. All right. And then to end it, to stop everything, we go back to our control. We use this stop block to stop everything. Now, the other ending condition that I want to check for is if the score reaches 10. So we can just go ahead and duplicate this if block again. So we're going to duplicate it, hook it in underneath the preceding one, and we're going to change it a little bit. So we're going to get rid of this lives variable, drag it over here, and we are going to use the score variable. But this time we want to check if the score is greater than something. So I'm going to lock it in on this side so that I don't have to pull out another operator. Either way works, if you do this or if you switch it around and use, let me see here, this. So you could do it like that or like that. So let's go ahead and put this one in here. And if the score is greater than 9, so that means the score is 10, 11, 12, or higher. So in this case, we're going to go ahead and again say something. We'll say you win, and then we're going to stop everything. So there we go. We've now added all of our code to be able to play this game. So let's try it out. Let's click the green flag. We see we start with a score of 1 because I'm already touching the donut, and our lives are at 10. Oh, the cat touched me, so I lost a life. Got another point, another point. If I hover on it long enough, I can gain a few more. and you can adjust that by adjusting the wait time. So I've lost a few lives now. Where'd the donut is hidden by the variables. There we go, one more point and I win. And everything stops. So there we go. That is a quick way to code the cat and mouse game. Alright, now that the Scratch game is ready, can you think of any way to improve it? Asking students to extend a project is a great way to get them to explore new concepts and to challenge those students who get done early. So one way I can think of to improve this would be to add a different backdrop that shows when the game is over, maybe with a clear, easy to read win-loss message. Another way might be to add a play again button that actually resets the game to an initial state. You notice that the cat, the mouse, and the donut all started the game each time in the same position that they were in when the game ended the previous time. So you could add some initialization values to put them in specific positions for when the game starts. Another way to enhance this project would be to adjust the difficulty level by changing the speed and movement of the sprites. Think about how you could do that. And then finally, you could make the cat actually chase the mouse instead of just moving randomly. So those are some ways that you could enhance and extend this project. Now, how about some closing tips and questions to reflect upon? So the first tip is that before you code something, you need to plan it. Planning is an integral part of good coding. Asking students to plan their project before trying to code it will help them to be successful and reduce their frustration. Planning occurs at 4 levels. Those are the problem level, the algorithm level, programming, and program execution level. Now, before you get to the program level, that's writing the program, the planning that you need to do is at the problem and algorithm level. So you should ask students to write out the problem statement in their own words. That's a good way to get them to start thinking about and breaking down the problem, decomposing it. And then ask the students to plan their algorithm. They could do that using natural language such as pseudocode or a flowchart or even just a storyboard. That'll get them to start thinking about what their algorithm needs to do. Now, students do not like to plan. They love to just jump in and start trying things. And this is why teachers should model planning so that students can see the benefits of it. So the second tip is to use live coding. Live coding is one of several strategies to scaffold coding. Some of the others include code reading, worked examples, use, modify, create, and prim. Due to the cognitive load of learning to code, it is recommended to use scaffolding before asking students to code independently. Live coding is where the teacher models the design and implementation of a program. The teacher talks aloud, sharing their thoughts as they make decisions while they're coding. And it's recommended to incorporate mistakes into your coding while you are demonstrating it to the students. Doing this is an integral part of live coding, and it's a great way to address student misconceptions as well as model how to handle a mistake so that they avoid getting frustrated. Now finally, how about some questions to reflect upon? One question is, which of these core concepts were used to create the game demonstrated here? Did we use event triggers, sequences, loops, conditionals, variables, or functions? And then finally, how did creating this Scratch game relate to Indiana's CS standards? Which ones were covered? Can you think of any non-CS standards that you could pull into a project like this so that you could cover some of the other goals that need to be covered in classroom lessons? That is all for now. Thanks for watching.